Okay, so problem 4.11. Let the sum from n equals 1 to infinity of a sub n be a convergent series, and the sum from n equals 1 to infinity of b sub n be also an infinite convergent series of non-negative terms. Okay, now we need to prove that this implies that the sum from n equals 1 to infinity of the square root of an bn is also convergent. And the hint is to use this inequality: x times y is smaller or equal than x squared plus y squared over 2, right? Now we have square root here, squares here, something like that. So you can try and see. Here we have that this is x squared over 2 plus y squared over 2, right? But we know, so we want to relate x and y to an and bn, right? Because we know that that way, because these two series are convergent, if we use this on this to the let's say that the comparison test we can apply, we can make sure that the let's say this series will converge, right? So let's see, we want to prove that this series converges. So let's see if we can write x times y is the square root of a n times bn. So in other words, x is the square root of a n and y is the square root of bn, right? So this is smaller or equal than x squared, this is a n over 2, and the y squared is bn over 2, right? So that means that the series of these terms, okay, this series, the general term of this series is smaller than the sum of these two general terms. Both series converge, right? So if we know that both of these converge, we can sum them. So the sum of an plus bn over 2 will also be convergent, okay? So this series is convergent. The general term of this series is greater or equal than this term for every n. So that means that this series is convergent, which is what we wanted to prove, okay? Now, as an application, prove that if the series of non-negative terms a sub n is convergent, then the sum of the square root of n over n will also be convergent. But now, so the application is we need to prove, in this case, that we have a second series b sub n that we know it's convergent, and when we write it like this, will also be convergent. But so we have a sub n bn, the square root of that, and we want this to be equal to the square root of a sub n over n. So that means that b sub n is actually 1 over n squared, and we know that the series b sub n, right, from n equals 1 to infinity, when b sub n is 1 over n squared, is also convergent. Okay, so then we have some sequences, some convergent series, and we know that the product, the square root of the product of the general terms will make a series that is also convergent. Okay, so we have proved the result, and that ends the exercise.